We'll start. Previous day I have discussed slight amount of alcohol, phenol, ether, just for alcohol. Today I will start vigorously for alcohol, different classification of the part. First, aldehyde, RCHO, reduction, very important, LiAlH4 or NaBH4. Aldehyde reduced, such reducing agent like lithium aluminum hydride or sodium borohydride, LiAlH4 or NaBH4, and then you will get that primary alcohol. This is the big point. This is the big point. And then ketone, that is the reduction of alcohol. That is the reduction of aldehyde and ketone. I am sorry. That is the reduction of aldehyde and reduction of ketone. Aldehyde reduced to primary alcohol, and it will take same reagent, LiAlH4 or NaBH4, like this one. That is the ketone. It will produce secondary alcohol. This is the main important point of the part, that it will produce secondary alcohol, 2-degree alcohol. That is the reduction of aldehyde and ketone. Another important part, that is very important part, that is reduction of A star, very important reaction. Reduction of A star or COOR dash. That is the A star. Reduction with sodium based reagent, sodium with ethanol, it will get a dashed OH plus or CH2OH. That is the mixture of primary alcohol. That is the mixture of, that is the very important question for JEE mains and West Bengal Joint also. This is the A star. This part will go to the dashed OH alcohol, and this one is also go to the primary alcohol. Only primary alcohol can be produced in this reaction. That is ester to alcohol, if you can use the conversion of ester to alcohol. Now, I will take the direct example. That means CH3 COO C2H. That means ethyl acetate. Ethyl acetate. That is the another example of ester. It will take 2 mole ethyl alcohol. One step, ethyl acetate to ethanol. That is the very, very important reaction. Extract to ethanol one step. That is a very important question for JEE Mains and NEET. You will mention the reagent. That is the best reagent, sodium in ethanol. One step ethyl acetate to ethanol. Then I will take alcohol synthesis. Alcohol synthesis, primary alcohol, secondary alcohol, and tertiary alcohol. 3 types of alcohol. With the help of Grignard reagent RMGX, that is called alkyl magnesium halide. That means Grignard reagent. That means Grignard reagent, and that is called alkyl magnesium halide. Alkyl magnesium halide. This X is chlorine, bromine, iodine. X is chlorine, bromine, iodine. That is alkyl magnesium halide. I will take the synthesis of primary alcohol, secondary alcohol, tertiary alcohol with the help of Grignard reagent. First, I will start primary alcohol. First, I will start primary alcohol except methanol. Except methanol. Methanol छोड़कर any primary alcohol you can synthesis with the help of the Grignard reagent. Okay, and this is also example of nucleophilic addition reaction. This is also example of nucleophilic addition. Very important reaction. Nucleophilic addition reaction. Except methyl alcohol. Methyl alcohol छोड़कर any primary alcohol can be synthesis with the help of this reaction, and starting material is, I will take the mechanism. Starting material is formaldehyde. Starting material is formaldehyde. Formaldehyde के साथ any Grignard reagent के रिएक्शन करेगा, उसका एडिशन प्रोडक्ट आएगा, उसके बाद हाइड्रोलाइसिस करेगा तो प्राइमरी अल्कोहल. So this is the technique. When formaldehyde reacts with Grignard reagent, first it will give the addition compound. After hydrolysis, that is the probable primary alcohol. What is the mechanism? This is CH3 MgI. That is the del minus, and that is the del plus. This del minus means that is the nucleophile. You can rupture this bond, then it will produce H, C plus, O minus H. This one goes to this angle, and this one goes to this angle, and that is H, C, O, MgI, H, CH3. That is the addition compound. After the hydrolysis, it will take primary alcohol like this one. So that is the big question. That means formaldehyde to ethanol conversion, you can apply this method. There is a very good reaction, and there is a very beautiful application of Greek-Trat reagent. In an enormous application of Greek-Trat reagent, when we will go to the aldehyde and ketone, then we can also apply the Greek-Trat reagent. Then secondary alcohol. Secondary alcohol means starting material except formaldehyde. The primary alcohol, starting material is formaldehyde. Secondary alcohol, starting material is except formaldehyde. That means I will take this one, that is acetaldehyde with Greek-Trat reagent CH3 MgI, that is del minus, that is del plus. You can rapture this one, it will get this one, and you can apply mechanism, and you will get CH3 C O MgI. That is an addition product. That is H, and that is CH. That is the addition product. After hydrolysis, it will get CH3 C OH H CH3. That means 2-degree alcohol. That means prop to all. Prop to all. That is the product. This is the synthesis of 2-degree. मैंने पाखड़ा चालू ना और ना अच्छा ठीक है. That is the 2-degree alcohol. That is the কি বললাম 2-degree alcohol. It will take aldehyde মানে acetaldehyde other than formaldehyde. It will take other any aldehyde. It may be ethanal, it may be propanal, it may be butanal. Then another Greek-Trat reagent like CH3MgBr, CH3MgI, something like that. Then first it will get that addition compound. After that hydrolysis, it will get that your desired alcohol, that is a 2-degree alcohol, prop to all. Clear it? Next one, I will take 3-degree alcohol. 3-degree alcohol. মানে ঠিক ফাংশন করছে না নাকি? আসছে এখানে। স্টার্টিং মেটেরিয়াল ইজ কিটোন। আপনি পাচ্ছেন? হ্যাঁ, স্টার্টিং মেটেরিয়াল ইজ কিটোন। তিনটা মনে হচ্ছে না, মনে হচ্ছে। ও আচ্ছা, স্টার্টিং মেটেরিয়াল ইজ কিটোন। স্টার্টিং মেটেরিয়াল ইজ কিটোন and Grignard reagent like this one, del minus del plus, rapture, done. Addition, hydrolysis, degree alcohol. I will take three different types of alcohol. That means primary alcohol, that means secondary alcohol, that means tertiary alcohol. Primary alcohol, in case of primary alcohol, starting material is formaldehyde. In case of secondary alcohol, starting material is other than formaldehyde, other any aldehyde like ethanol, propanol, butanol, like that. And in case of tertiary alcohol, I will take that ketone. Here, and this example is also applicable conversion of aldehyde to alcohol, primary alcohol, aldehyde to secondary alcohol, ketone to tertiary alcohol. There is the big example of the application of the Grignard reagent. When aldehyde reacts with Grignard reagent, it will produce primary alcohol. When aldehyde reacts with Grignard reagent, it will produce secondary alcohol. When ketone reacts with Grignard reagent, it will produce tertiary. Then I will take the good example. This is a various example of the part Rx, magnesium in dry tar, identify the compound A, then epoxide, and then epoxide, that is called cyclic ether. Epoxide, ethylene oxide or epoxide, very important question for any competitive examination. Then it will hydrolysis, identify C. That is the big question. That is the big question. Alkyl halide reacts with magnesium in dry ether. First, it will produce RMgX. That is called alkyl magnesium halide. That is the first it will produce that Grignard reagent. After that, it will produce RCH2, CH2, OMGX. That is the addition compound. After the hydrolysis, RCH2, CH2, OH, that is primary alcohol. Here, there is another example. That is another example of the Grignard reagent I will start from alkyl halide. I will start from alkyl halide. After that, that is Richter reagent. Then this is epoxide. Epoxide. Then addition compound. Then primary alcohol. Okay. Next, I will start for another example, that is hydroboronation oxidation reaction. Hydroboronation, hydroboronation and oxidation. Hydroboronation and oxidation. That is also primary alcohol synthesis. That is also primary alcohol synthesis. That is also primary alcohol synthesis, and that is under anti-Markovnikov rule. Anti-Markovnikov rule. Anti-Markovnikov is first step is the hydroboronation. First step, the hydroboronation, and second, I will take the example. And second step is the oxidation. देखा जाक क्या होता है. This is the propene. P2H6. P2H6, that is diborane in PHF. This one. Trialkyl borane. That is according to the anti-Markovnikov rule. That is yield of primary alcohol. Got it? Agree? Very important question. Very, very important question. I will start some conversion. Different alcohol. Lower alcohol to higher alcohol to lower alcohol, primary alcohol to secondary alcohol to primary alcohol, alkene to primary alcohol, alkene to secondary alcohol, alkene to tertiary alcohol, various type of conversion of different types of alcohol. First, I will start, that is methanol. to ethanol. That means lower alcohol to higher alcohol. Means carbon number increases. Lower alcohol to higher alcohol. That means carbon number increases. I KCN CH3CN primary amine. That is lower alcohol to higher alcohol conversion. That is lower alcohol means methyl alcohol, higher alcohol means when carbon number increases, then first you will take that alkyl halide, then react with CH3CN, then methyl cyanide, then carbon number increases. After that, sodium ethanol, that is the well-known reagent, reduction of sodium ethanol, it will get the primary amine. Primary amine reacts with nitric acid to get methanol, ethyl alcohol. That is lower alcohol to higher alcohol conversion. Next one is the reverse one. Next one is the reverse one. Ethanol to methanol. higher to lower, higher to lower. Previous one is lower to higher. Probe one all. Two probe two all. That is another conversion. Probe one all to probe two all. That is another conversion. Here, done. And anti-Markovnikov rule. This one. Next, write down. That is 2-degree alcohol to 1 degree. Next conversion, that is 2-degree alcohol to 3-degree alcohol. That is 2-degree alcohol to 3-degree alcohol. Okay, very important. This one, agree? Oxidation, sulfuric acid, ketone, done it, done. 2-degree alcohol, prop to all, tert butyl alcohol, tertiary butyl. Clear? Next one. Another conversion I will take. Tertiary butyl alcohol, tert butyl. Tert butyl alcohol. Tert butyl alcohol, if you take the UPAC, then 2-methyl prop 2-all. That is 3-degree alcohol. Convert to CH3 okay, that is 1-degree alcohol. Okay, I will take the another. This is the example. First, anti bar kori ko. Next one will go to then clear? Clear? That is 3 degree alcohol, that is 1 degree alcohol. Done? Different types of conversion. Next. Another one is alcohol plus halogen hydrous. It may be primary alcohol, may be secondary alcohol, it may be tertiary. And halogen acid means HI, HBr, H. Reactivity of halogen acid, HI greater than HBr greater than HCl. Okay. In case of primary alcohol, that is under SN2 mechanism. In case of secondary and tertiary alcohol, that is under SN1 mechanism. In case of primary alcohol, I will take the mechanism. In case of primary alcohol, that is an SN2 mechanism. In previous class, I have details discussed in SN1 and SN2 both. That is the application. In case of primary alcohol, that is under the SN2 mechanism. In case of secondary alcohol, primary alcohol, that is the SN2 mechanism. In case of secondary and tertiary alcohol, that is the SN1 mechanism. First, I will take the example. First, I will take the example. This is the example. That is the primary alcohol. That is the mechanism. Then I will take any example, either secondary or tertiary. that is goes to an SN1 mechanism. And I will take this one. Okay, there is a 3 degree alcohol. L plus, L minus, and that is the 3 degree carbon. That is the first step. That is the first step. এটা কি গন্ডগোল হলো নাকি? That is the first step. Then carbocation. That is the first step. 3 degree carbocation. Stable carbocation. SN1 mechanism. And second step, I minus this is the part. This is the part. This is the part. I will take some example. Various example. In that case, SN1 in tertiary alcohol, rearrangement reaction also can occur. In tertiary alcohol, rearrangement reaction also can occur. Rearrangement reaction also can occur. I will take the example of neopentyl alcohol. Neopentyl alcohol. I will take this example. Along with HI, identify A plus. Done it. Neopentyl alcohol. That's primary alcohol. That is the SN2 product. Minor product. Important for entrance. Done. Migration. Degree. I minus. Attack. That is under measure. That is under SN1 mechanism. Yes or no? That is under SN1 mechanism. Next one. Dehydration. Hydration. Of alcohol. 3 degree greater than 2 degree greater than 1 degree. That means 3 degree alcohol is much more easily dehydrated compared to 2 degree alcohol compared to 1 degree. That is the dehydration of alcohol. 3 degree greater than 2 degree greater than 1 degree. That means 3 degree alcohol is much more easily dehydrated compared to 2 degree compared to 1 degree due to formation of stable carbocation. I have already discussed it. Next one. Next one, physical property of alcohol. Physical property of alcohol. Physical property. One is BP, BP in short, that is boiling point. Another is solubility. First, I will discuss solubility. After that, I will discuss boiling. These are two very important topics. And these two topics mainly depends on hydrogen bonding. It's much more soluble in water due to hydrogen bond. Alcohol is much more soluble in water due to key hydrogen bonding. Ether, no hydrogen bonding. Insoluble in water. So alcohol is soluble in water. Ether is insoluble in water. Another one is lower member of alcohol, lower member of alcohol is much more soluble than higher member of alcohol. So in between alcohol and ether, alcohol is always much more soluble compared to ether due to intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Yeah? The big part, physical property. Another one is BP, in boiling point, compared to ether. And also in isomeric alcohol, boiling point increases from primary alcohol to secondary alcohol to tertiary alcohol. Primary alcohol to secondary alcohol, primary alcohol greater than secondary alcohol, greater than tertiary alcohol, due to Van der Waals force. I will discuss. First, any alcohol hydrogen bonding with another alcohol, and ether cannot form any type of hydrogen bonding. So boiling point of alcohol is higher than ether. Any class of alcohol with any class of ether, and that is also intermolecular hydrogen bond. Intermolecular hydrogen bonding. Done? Yes or no? Then I will take the example. One butanol, two methyl one butanol, two methyl one propanol. I am sorry. That is the one butanol. One. Oh, sorry. Extremely sorry. That is one butanol. Next one is 2-methyl one propanol. This one is another one is means 3-degree alcohol. Compare BP, compare boiling point. Compare boiling point. That means this is the straight chain compound. All OH, all are responsible for hydrogen bonding. Done. But this is the primary alcohol straight chain compound. Surface area increases. That means van der Waals force increases. This is also primary alcohol. 1-degree alcohol, primary alcohol. Branched one, surface area decreases. This is the 3-degree alcohol. This is much more branched, then surface area is much more close, just like spherical. For this reason, these two are weak van der Waals force. Weak van der Waals force. For this reason, compare the three types of alcohol. Boiling point 1 greater than 2 greater than 3. Write it. Done. In between primary alcohol, secondary alcohol and tertiary alcohol, boiling point does not depend on hydrogen bonding because all class of alcohol is responsible for hydrogen bonding. Then if a straight chain compound, then van der Waals force increases. There is a branched one, van der Waals force decreases. Much more branched, van der Waals force much more decreases. Clear it? Next. Alcohol reacts with metallic sodium. RONA. That is sodium alkoxide. These properties show acidic nature of alcohol because hydrogen is replaced by strong electropositive metal. These properties show acidic nature of alcohol. Any type of alcohol reacts with metallic sodium to form alkoxide. Sodium, it may be potassium or it may be potassium. That is called sodium alkoxide. This one, 1 degree, 2 degree, sorry, and 3 degree alcohol. I've discussed two questions. That is primary alcohol, that is secondary alcohol, and that is tertiary alcohol. Compare acidic nature. Acidic nature. Compare acidic nature. Clear? Yes or no? That means there is 1 plus I effect. Two plus I effect. Three plus I effect. Plus I effect means keep push. Plus I effect always decreases the acid strength. So for 3 classification of alcohol, primary, secondary and tertiary, acidic character or acid strength order 1 degree greater than 2 degree greater than. Clear? Next one. Comparison between alcohol and phenol. Acid strength. These are very important topics. That in case of phenol, there is a resonance. There is a 5 types of resonance, and that belongs to N plus R resonance. In case of alcohol, there is no resonance, but on the other hand, there is an plus I effect. And due to resonance, oxygen atom gets positively charged. So, it can release proton much more easier because these bond strength are weaker. These bond strength are weaker. So, it can release proton much more easier. For this reason, due to, this is a big question, for this reason, due to resonance, phenol is much more higher acid strength than any type of alcohol. I will give some variation of acid strength character because phenol, due to the resonance, oxygen atom gets positively charged, strength of OH bond are weaker, so it can release proton much more easier. But on the other hand, any type of aliphatic alcohol, there is no resonance, but it will take the plus I effect. So it is much more difficult to release the proton. For this reason, any type of alcohol is much more less acidic character or less acid compared to phenol. I will give some typical example of the entrance question. Compare the acid alcohol, phenol, water, H2CO3. This is the entrance question, purely entrance question. First one. Second one. Third one. And alcohol is the last one because there is a plus I effect. Even water, there is no plus I effect. Inorganic acid is always higher acid strength than organic. So first one is carbonic, second one is phenol, third one is water, fourth one is alcohol. Next one. I will take some example. Acid strength of phenol. Minus I effect or electron withdrawing group like NO2, CN, CHO, etc. increases the acid strength, etc. increases the acid strength. Increases the acid strength. On the other hand, plus I effect, like alkyl group, mainly for alkyl group, decreases the acid strength. This is the very important topics for entrance exam. Phenol itself is a higher acid strength than any aliphatic alcohol. On the other hand, any substituent, including phenol, it may be ortho, meta, para, whatever may be, minus I effect or electron withdrawing effect, just like NO2, CN, CHO, etc., increases the acid strength of phenol. Plus I effect mainly means alkyl group, methyl, ethyl, that is plus I effect, which can decreases the acid strength of which can decrease the acid strength of phenol. One thing remember, that is also sodium phenoxide. That is also sodium phenoxide. Hello? That is also sodium phenoxide. I will take some example. Phenol assistant. Phenol that is para-nitrophenol, para-nitrophenol, that is two comma four dinitrophenol, and another one, two comma four comma six trinitrophenol, that is called picric acid. That is called picric acid. There is phenol, there is no other groups. In that case, minus I effect, 1 minus I. In that case, 2 minus I effect. And in that case, 3 minus I. Minus I effect increases the acid strength. And this is the picric acid. Write down. Strongest organic acid. Even it may be parallel to any carboxylic acid strength. Later I have discussed this one when compared with phenol and acid, carboxylic acid. So option is 4 greater than 3 greater than 2 greater than 1. That is an option. Phenol, there is no plus I minus effect group. Para-nitrophenol, there is an para position is minus effect group. 2 comma 4 dinitrophenol, there is a 2 minus I effect group. And 2 comma 4 comma 6 trinitrophenol, I will take that the picric acid, that is the strongest organic acid. Done it? Next one. I will take some another example. That is phenol cyclohexanol benzyl alcohol. Compare the assistant. Compare the assistant. Okay. This is the phenol resonance, highly resonance stabilized. This is the cyclohexanol. Cyclohexanol. And this is the benzyl alcohol. In case of cyclohexanol, there is no plus I effect, there is no minus I effect, there is no resonance. But in case of benzyl alcohol, C6H5 have small minus I effect. So option is highly stabilized by resonance. Resonance always increases the acidic character. So 1 greater than 3 greater than done the problem. Madam,